All right, welcome Math 30-1. So today we're going to look at how to graph a polynomial function. That's going to be our objective today. So the first thing you need to look at is multiplicity. So multiplicity is a pretty important term moving forward. Okay, with multiplicity, what it means is how many roots you have or how many zeros you have. So for example, some things you need to know. If you end up having a multiplicity of 1, then your graph is just going to cross right at 1, just like this. Okay, so this root right here, or this 0, would have a multiplicity of 1. If you have a multiplicity of 2 or any kind of even multiplicity, your graph is actually going to touch the x-axis and then bounce back. So that would be a multiplicity of 2. If you have a multiplicity of 3 or any odd multiplicity, it's still going to cross the x-axis, but it's going to bend as it crosses. So this would show you a multiplicity of 3 or more. Generally, when we're working with multiplicities, it'll be 3. Okay, so when we look at these two examples here, we know this is a cubic graph. Okay, we also can see that it has 3 zeros. So it has a 0 here, here, and here. All of these zeros would have a multiplicity of 1 because they all cross and none of them are curving as they cross. Okay, in example number 2, we know that this would have a degree of 4, this particular graph. Okay, and that's kind of a giveaway by the end behavior here. And also we have the 4 up there, and it has 4 zeros. Okay, so we're going to write some examples here using some information. So first off, we're going to write a third degree polynomial with roots 2, -1, and 4. The first thing you should know is there's actually an infinite amount of correct answers here, and the reason being is because of your a value. So when we write polynomial functions, a lot of times when we're dealing with multiplicity, we're going to write in factored form. Okay, but don't forget, when you write in factored form, you will have an a value. So I'm going to choose an a value of 5 just because I want to. Okay, now to figure out the factors in this third degree polynomial, I'll use the roots. So first of all, I have a root at 2, which means I need to have a factor of x minus 2. If I have a root at -1, I need to have a factor of x plus 1. If I have a root of 4, I need to have a factor of x minus 4. You could go ahead and graph this equation, and you should see those 3 roots in those places. Okay, so now we have a third degree polynomial. It says it has an equation of with roots -2, multiplicity of 2. So let's write an a value to start with. Let's pick 3 for our a value this time. So if we have a root of -2, that means we have a factor of x plus 2. It has a multiplicity of 2. And we have a root of 4. So that means we'll have a factor of x minus 4 and a multiplicity of 1. And there we go. All right, so let's actually look at graphing. So here, when I look at this graph, I have a 0 at 2, so I'm going to draw a 0 there at 2. I have a 0 at -3, so I'll draw a 0 at -3. And I have a 0 at -1. So my 0 at -1, I know that this, because it has a multiplicity of 2, meaning it appears twice, it's going to touch -1. While these two zeros have a multiplicity of 1, which means they are going to cross the x-axis at those two roots. The other thing I'm going to pay attention to is my end behavior. So in this graph, I have a positive a value, which means I'd have an end behavior, okay, that was increasing in nature or going up. So if I end up having a degree of 4 and I end up going up or opening up in this case, I know my graph should look something like this. So I should have an end behavior from quadrant 2 to quadrant 1. The other thing I can take note of course, is my y-intercept. So my y-intercept, I'll end up multiplying all of these constants. So -2 times 3 gives me -6 times 1 gives me -6 times 1. So I have a y-intercept at -6. So So now I know I start in quadrant 2. Okay, so I'm going to start in quadrant 2, cross at -3, touch at -1, go down to my y-intercept, back up. Of course, this is a rough guess based on what I know. I don't actually know how far my local minimums would be. I would need to graph that to get that exact point. This is the general neighborhood. All right, here's an example of a diploma question. So sketch the graph of a 5th degree polynomial, so 5th degree, with one real zero of a multiplicity of 3 and a negative leading coefficient. Lots of different examples here. So actually what I would probably do is I would just write an equation. So I know I need a negative leading coefficient, so let's pick a -1. I need a 0 with a multiplicity of 3, so let's just make a 0 up. So let's go x plus 2 with a multiplicity of 3. 5th degree polynomial, so I need just 2 more random factors here so that I end up with a 5th degree polynomial. So now that I have a polynomial written that matches these descriptions, I'm going to go ahead and graph this on my graphing calculator so that I end up with a more exact graph. Okay, and whenever we're graphing, we're looking at some key points. So I'm looking for those roots, those x-intercepts, making sure they're in the right place. So if I have x plus 2, I know I need to have a root at -2. If I have x minus 1, I need a root at +1 and also a root at +2. So our y-intercept, I'll also pay attention to. It's at -16, so it's going to be way down here. All right, so when we look at our graph, okay, because we have a 5th degree polynomial and we have a negative leading coefficient, our end behavior is going to be from quadrant 2 to quadrant 4. So I need to start somewhere in quadrant 2. Because I have a multiplicity of 3, when I cross here, I'm going to bend as I cross. I'll go down to that y-intercept and then cross between these two other x-intercepts. So my graph's going to look something like that. Again, infinite possibilities, lots of different graphs you could have drawn and equations you could have written that meet these descriptions. Okay, so let's look at some more diploma questions. So here it says, what is the minimum possible degree? When we look at the end behavior, we're going from quadrant 3 to 4. I see a 0 here at -3 with a multiplicity of 1. I see another 0 here at +1 with a multiplicity of 1. And then another 0 here at 5. Because it touches and doesn't cross, it has a multiplicity of 2. So now that I know this, can I write an equation? So let's try that out. So we have y equals, remember when you're writing in factored form, don't forget your a value, okay, because we don't know what that is, that leading coefficient. And then we're going to just write our 0. So if we have a 0 at -3, it means we have a factor of x plus 3. Because it has a multiplicity of 1, the degree of this factor will just be 1. Next I have a 0 at 1, which means I have a factor of x minus 1. Again, it has a multiplicity of 1, which means the degree of my factor will be 1. Lastly, I have a 0 at +5, which means I will have a factor of x minus 5. Because this has a multiplicity of 2, however, the degree of my factor will be 2. So now that I have this written out, I need to find my a value. To find my a value, I could use any point on the graph. However, I'm going to use my y-intercept because it's a clear point on this graph. So if you look there, when x is 0, y is 1, 2, 3, 4. Looks like it's crossing at 5 there. So y is 5. So now that I have this point on my graph, I'll go ahead and substitute that point in. So when y is 5, x is 0. From here, I can go ahead and type this in my calculator. So I end up with 3 times -1 times 5 squared. Oops, I accidentally Scrolled ahead there, gives me negative 75. Okay, and then to solve for a, I can just go ahead and divide that negative 75 over, and I'll use math fraction. In lowest terms, my a value is negative 1 over 15. That 15 is hard to see. So I'm not quite done there because it does want that equation in factored form. So I know my a value is negative 1 over 15, and I'm just going to rewrite that equation with all those other factors that I already figured out by looking at the graph. There we go. Excellent way to double check if you're unsure. Graph it. Does it match the picture? If it does, you know you did it correctly. Okay, so here's another diploma question we're going to look at really quick here. Okay, so when I look at this graph, some things I'm automatically going to notice is because my end behavior is from quadrant 2 to quadrant 4, I know this graph is going down in nature, which means it's going to have a negative coefficient, leading coefficient. I also know because it's going down from left to right, it's also going to be an odd degree polynomial. So when I look here, I actually can just look at my options between equation 1 and equation 2. So equation 1 would have a degree of 2 plus 3, which would be odd. Equation 2, because of that x there, it would actually have a degree of 5 as well. However, this x in the second option, because it is a factor of x, it would mean you'd have a 0 in the origin, okay? Or an x-intercept at 0. We don't see that on this graph, so we know equation 2 is not possible. So we are looking at equation 1. So something else I'm going to look at now, multiplicity. So here I'm crossing and bending as I cross, which means I need to have a multiplicity of 3 at this 0. Here I'm touching the graph without crossing, so I have a multiplicity of 2. Now that I know this, let's see if we can figure out the correct equation. So we know we have a negative a value. If I have x minus b, notice how the negative is already there. And we could just let's make up some numbers here. Let's say this is 1 and this is negative 5, just so that we have an equation to work with. So we would say here, because this is a positive 1, I'd have x minus 1. It has a multiplicity of 2. Okay. Here, because this is a negative 5, I'd have x plus 5 with a multiplicity of 3. So we know our b value then, in order to have a multiplicity of 2, the b value has to be positive, right? Because that's this positive 0 over here. And my c value would have to be negative. So then that means if my b value is positive and my c value is negative, I'm looking at code 5. So then my code would be 1, 4, 5. Okay, time's sake, we're going to skip this question. You can try that on your own if you want to. Just going to look at 2 quick diploma questions before you leave. So I have a cubic function. It gives me the zeros of that function, and it gives me a point on the graph. Notice how that's a point on the graph. It's the y-intercept, but it's still a point. So I'm going to write this equation out using those zeros. Because it's a cubic graph and there's 3 zeros, it means that all of these zeros would need to have a multiplicity of 1. Now that I have this written in factored form, I'll use the point on the graph to find my a value. So I'm just substituting that point in here. Oops, I jumped ahead, or jumped behind, I guess. So I have 0 plus 3 gives me 3, times negative 1 gives me negative 3, times negative 2 gives me a positive 6. So that means my a value would need to be negative 2. So now that I know my a value, this of course is function notation, so it's just asking what your y value would be when x is 3 over 2. So let's write this equation out. We'll replace x with 3 over 2. And then from here, we can just type this in our calculator and get a y value. So if I type it in, I'd have negative 2 bracket. 3 over 2 is the same as 1.5, so I can use the decimal there so it's easier to type in. Okay, and then I end up with an answer of 2.25. All right, last question, another graphing question. It's asking for the equation again. So let's look at what we know. So we have a 0 at -6, which means I need a factor of x plus 6. It crosses, so it has a multiplicity of 1. We have a 0 at -2, which means I have a factor of x plus 2. It's crossing, which means it has a multiplicity of 1. Here I have a 0 at 2, which means I have a factor of x minus 2. It's touching, which means I have a multiplicity of 2. And then the other point they give here is a y-intercept. Once again, I use the y-intercept as a point on the graph to help me find that a value. So I'm going to substitute it in. So when y is 96, x is 0. So there I am substituting that point in. So now I'll type this in my calculator. So I have 6 times 2 times -2 squared, and I end up with 48, which means my a value has to give me 2. Again, love this question because it's so easy to double check. Now that you know your equation, you can go ahead and graph this. Check your table of values. Do all of these points show up on your table of values? If they do, you did it correctly. There are some questions for you to try. Again, you can do all of them if you want. You can pick and choose to whatever you need to do to make sure you understand the concept. Thanks, Math 30-1. I hope you have a great day.